Hi there! In this video we are going to create a training pipeline and see how we're going to use tests for testing different stages of our training pipeline, starting from raw data quality to features quality and finally models performance. So let's run our Jupyter notebook. I already have my one, and create a new example. I will call it training pipeline. Our training pipeline validation. Next step would be to import libraries we need to use later. It will be scikit-learn for dataset selection, for model training, right? It will be pandas to create a data frame, and it will be a couple of things from evidently like report and some presets. So let's do that. And I just remembered that we need also to import pickle because we are going to save our model in order to later be able to load it from file, right, and use it when we do our prediction pipeline. And pickle is the library which helps us to save Python objects to a file system and load it back. So that's very useful here. I believe that's it. If we need something else, I will come back to the first cell and import it as well. So now let's load our dataset, and as I promised before in the previous video, we're going to use bank marketing dataset to play around with our training pipeline. I'm going to load this dataset with help of fetch OpenML function. So we just imported the dataset and then created the data frame from the initial dataset. Here it is. Next step would be to analyze what do we have inside of this dataset, and I already prepared for you some attribute information which I derived from the OpenML website, and let me just place it here for our convenience. So we can see that we have quite a lot of attribute information like client data, its age, job, marital status, education, default, balance, etc. I also have some data related to the last contact from the bank, which is contact information. No, it's contact communication type, right? It can be cellular, telephone. It's the day, right? It's contact day of the month, numerical feature luckily. Its month is duration of the contact, so we can create a picture of how it went, right? And finally we have some other attributes like campaign, p-days, which is the number of days that has passed since we last contacted this client. The previous, this is the number of contacts performed before this campaign, and finally p-outcome, which is the outcome of the previous marketing campaign, right? So that's the attributes we have, and we have target as well. And let us see how the data frame looks like itself. I really like to use method info because it helps me to figure out how big my dataset is, right? So I can see that it takes 2.8 megabytes, and I can see the types of my columns. So no empty data, luckily, and I have both categorical and float numerical features. So okay, wow, we have like 45,000 entries, which is great because we are going to use this dataset to simulate the production batch usage of our model. So we need to split this dataset into the train, reference data, and all the rest data which we're going to use to simulate the batch usage of our model. So let's see how it looks like in terms of columns. I'm going to use method head. That's our dataset, and unfortunately the names of the columns are not really readable, so we will need to create the better names. And what I suggest to do next is to create a function which we will use to pre-process this dataset into a suitable format. And by suitable format, I mean numerical features, so that we can train a model on top of this data frame, and readable column names as well. So what I'm going to do here is I'm going to leave the numerical columns as they are now and transform my categorical columns using the one-hot encoding method. If the column has quite a lot of categories, I'm going to use one-hot encoding. If it's the binary column, like yes, no, or maybe yes, no, and unknown, I'm going to just in place replace the yes by 1, no by -1 or something like this, and unknown by 0, so that I can just not create a lot of binary columns, but just replace the one. So for binary in place transformation, for many categories, one-hot encoding. Let's do that. I will create function feature engineering, and we're going to see how we can transform our dataset. Well, I believe that's going to be hard like this, so let me first just replace the name of my columns, and then I will create this function, because, well, it's really hard to work with that names. I will try to guess the right order just by the values of my data. So first is definitely age, then probably job, and etc. And now let's preview our data again, so that we see the correct names. Yeah, now it's much better. Now let's implement this feature engineering function, and this function is supposed to take the raw data in the format of pandas data frame as an input and return for us pre-processed pandas data frame as well. And I will start from the copying of our raw data, because I do not want to harm data by mistake, and I will do all the preprocessing with the copy of my initial data set. I will call it preprocessed data. And well, now let's implement all our changes. We will start from passing the right column names, because that's what we did just right here at Hawk, but when we will get the new batches of data, there won't be any right names, right? So that we need to implement that. And my next step would be actually pretty long, because I need to implement the pre-processing for all categorical features. Let's see. I'm afraid it will be a little bit boring, but we need to implement it once. Oh, for some reason I decided to start from this hasDefault function, just because it's yes and no, and I would like to start from such binary kind of features. Let me check the values, because I'm not sure it's actually binary. So it's default. Yeah, luckily it is binary, so I can just implement the lambda function here. And let me check as well this housing and loan, because I'm gonna do pretty similar things. Okay, good. All those features are binary, so I'm going to implement the lambda function to just transform it from yes and no to 1 and -1. Finally, I suggested to go with this kind of implementation, so I will have 0 if the value is equal to no, and 1 if the value is equal to yes. If not anything like this, I would have -1, because actually during the production data preprocessing, we cannot really rely on having this yes or no, because sometimes you might have some missing data, or maybe something else could possibly happen with our data. So I prefer to, instead of like broken preprocessing, have this special -1 value, and in case I need, I can implement test which checks whether I have any -1, so that I can see what's going on with my data. So it might be just slightly more convenient, but of course it's all up to you to decide how exactly you preprocess your raw data. That's how I decided to do it right here, and you can follow the other logic as well. So now let me quickly come up with all the rest binary features here. Basically, that's all binary features, and now let's apply one-hot encoding to all the categorical features. I believe I will be happy with somewhat like this. So what I did, I just created this dummy variables on top of this marital feature, right? Then I used this marital prefix so that later I can tell what was the initial feature. And then I'm going to just concatenate my initial data set with these dummy features. And I'm doing by axis1, which is like x-axis, right? So it will be joined and additional columns will be just added to my initial data set. It's kind of looks like some spaghetti code, but I believe that's the fastest way for me now implement that. So I'm going to just repeat the same logic for all other categorical features. Let me check. Well, oh, we have quite a lot. So I would ask you later to send me a pull request with this optimized feature engineering function. And let me just continue to do it so that we have our preprocessed data. And I would better do it by the group of columns so that I can check that I never forgot any of columns. And after I created all these dummy variables, I need to get rid of the initial data, right? So I'm just going to drop some old columns from my copied dataset. That's actually why I created the copy. And now I'm not really scared to like drop any columns because I'm not going to lose any data. Now I'm going to implement very same things for my last contact data and other attributes. We also have previous campaign outcome, so let's pre-process this as well. And finally, we have our target function, which is called class now, and I prefer to implement here two things. First of all, I would rather call it target instead of class, because class in Python is not very good name, right? And instead of like having 1 and 2, I believe, let me check. Actually, I'm going to show you why class is a bad name. So you can see, right? Not very useful, and I have to do the other syntax here. Yeah, so I have 102, and I prefer to keep it like 0 and 1, 0 for like non-success, right, when the customer does not subscribe, and 1 is for success. It's just more standard notation, and doing it like that, I remembered, I'm sure that I will not forget how I encoded my target events. So let me do that. And the last thing I need to do here is return my process data. And well, remember that that's just an example, right? And in your production pipelines, I would suggest you to either re-implement this function in order to keep it more optimal and less spaghetti, right? Or maybe split it into different parts and pre-process like at least a bunch of the columns separately. So it's just good practice to avoid such long functions anyway. And yes, so now let me apply it, but before that I would rather split my data into parts, because I'm going to use some data for training, some data for reference, and some data for production usage simulation. And here I would like to make pretty unexpected thing from data science point of view, because I'm going to just, well, suggest us to treat this data as a log, right? And maybe just imagine that there is some order of the data, so that I will use first part of data for training, just assuming that data is sorted by time, right? And I'm never like use the older data for train before some previous data. So I assume here that my data is ordered by time, right? And in this case, I'm going to split it this way. So for train data, I would take first, I believe, 5,000 rows, for reference data next 2,000 rows, and all the rest for production simulation. Let me at least try to do it like this, and we will see whether it's a good idea or not. As promised, for train first 5,000 rows, second 2,000 goes to reference data, and all the rest goes to production simulation data. And you can see that my batch size is equal to 2000. Let me just create this variable, because I believe it will be pretty useful later. That's it. And again, this is just an example, right? In the reality, probably you won't have all this data in the same place. Probably you will get it like batch by batch. And here we assume that we every time get a batch of data, which is the 2000 rows length, right? So that's what we do here. And well, now let us try to apply our feature preprocessing for our data, so that we can at least see whether it works or not. So I'm going to create my process train, process reference, and processed production simulation data, hopefully. So far I have an error only at the very end of our long function, right? So let's see. Well, at least it works. And same for reference data as well. And you guys will have much more time to play around with this feature engineering, so I really suggest you to do that. And I will stop myself here. So now I have my first step of the pipeline, which transform my raw data into pre-processed data. Actually, I'm curious to take a look how it looks like, because we actually never seen. So let's do it. Let's spell it correctly, and well, now I really like it much more. No, something is not right here. Let me go back to my function. Yeah, I can already see what's wrong, so yeah, please be careful with such functions. Yeah. Yeah, well, now I believe it should be fine. Let's quickly check, just at least visually. Okay, now I really like it. So let me make sure that there are no categorical features anymore. For doing that, I'm going to use info function. Some categories, but yeah, that's our binary function. Yeah, so that's okay, but at least we do not have categorical features, right? So yeah, happy we are. We have 47 features and the target column, so that's good. Now let us do some model training so that we can see that we have all the steps of our pipeline, and then we are going to implement the checks for raw data, process data, and model training. So our last step of our training pipeline would be actually to train the model. In order to save some time for hyperparameter search and actually any experiments, I'm just going to use the random forest because it's robust to overfitting, right? And I can really just go for a good baseline here. I would specify some random states so that you can have very same results, hopefully. And let me limit the number of estimators so that not to wait for too long for a model to be trained. Yep, here we go. Now we need to train our model, and let me quickly check how I can what's going on here. Just process data. Okay. Process train. What I'm going to do now is see how I can access all features and the target, and my idea is that I can rely on the order of the columns. Again, not very robust, but I believe you can do it here, just for the sake of fast code writing. Yeah, looks like a good strategy, and in order to access the target, probably, well, I can just call it by name. So, okay, let's train a model. My features and now target. Okay, we have a trained model, and now let's create some outputs, right? Because we need to assess model's quality. I would just add the column to initial data frames. So it will be my process data and processed reference data. What's going on here? Oh, wrong. Oh, actually, we'll have to rebuild all the things, right? Well, no worries here, it happens. Luckily, we can just rerun the slicing of our data, right? Everything actually. Model can be the same. So let me just rerun my feed. And now should be fine. Okay, I do hope, guys, that's our final step. Yeah, so let me check here. Yeah, I managed to create two separate data frames finally. So, okay, let's just, in case, retrain the model. And finally generate two data frames. So you see, it's not that easy actually. Okay. Let's put here correct data frame. Yep. And probably that's it. Now finally it's time to evaluate our training pipeline, and I'm going to use evidently reports for that. So that should be the easiest part of our journey so far. I would call it model evaluation. And let's go for our pipeline checking. Here I would raise or create model quality report. And as metrics, we will pass classification preset. Here we need to specify reference and current data. So reference data would be trained data. In our case, just because we need to assess quality on training data set anyway, right? And as the current data, we're going to use the future reference data set. And this is totally okay because that's the next batch of data we have right after training in our so-called prediction data, prediction logs, so that I can just pass the reference data here because we assume that our data have some order, but it should be processed reference data, right? Processed reference, okay. And well, let's explore the visual report right here inside of Jupyter Notebook. Yep, so let's see. Well, we have a very nice report here, and we can see that on top of the training data set, we have ideal model, which is not always good because it kind of looks like overfitting, but let us keep our model like it is now. I'm quite happy with the quality. Now let's see what we have on top of our reference data, and here we should be careful because that's the reference data set which we are going to use as a basis for comparison later, right? And well, we have quite low, I would say, precision and recall, right? But let us assume that we are happy with the model because I don't really spend quite a lot of time for model retraining. This video is already quite long, right? So let's assume that that's good baseline. And well, you can explore all the other metrics like confusion matrix. Well, actually, I would say that it's quite okay. Yeah, we can say so. It of course depends on what type of error we optimize, whether type 1 or type 2 regard this one label, right? And probably that's okay. So let us do the following thing. Let us save our model so that we can reuse it later. I'm going to save it with help of Pickle, and we will perform data quality and data drift checks in our next video. So the last thing I'm going to do here is to save our model, and so that later we can perform all the needed checks and see how it works. So I'm going to create a file for writing. And I'm going to have write binary specification here, each VB. That's our model saved right there in this working directory. And finally, I would suggest us also move our feature generation function to a utils module so that we can import it in other scripts. I just don't really want to re-implement it. So let me create the Python file. Okay, and what I'm going to do is I'm just going to yeah, now it's fine. And let's be careful because, yeah, at least we need to import pandas data frame. So import SSPD. Yeah, here we go. So this is how we created the module with only one function, feature engineering, and later in our next videos we are going to use it and just import it from, for instance, utils. We are going to save this module as utils.py. Basically that's it. We just did all our steps to create all the assets and build our training pipeline. So now our training pipeline consists of steps of loading raw data, performing feature engineering and model evaluation. And in our next video, we are going to assess the data quality, data stability and data drift before and after feature engineering so that we can see how good our pipeline is. Let's do it.